So the question is saying that sketch the polynomial function. Sketch this polynomial function. So number one, the first thing that you do is you find the roots. Okay, you find the roots of this polynomial function. So how do we find the roots? By trying out the different values of x, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus. Okay, try out these values until you get the value of x which is giving you, which will give you find the value of x such that f of x will be equal to 0. So let's try. Let's start with x is equal to negative 1. Okay, if x is equal to negative 1, we substitute negative 1 in the given function. We're going to get minus 1 cubed minus 7 minus 1 plus 6. Okay, this is going to give us minus 1, this is plus 7 plus 6. Then this is going to give us a 12, okay, which is not equal to 0. So this means that x plus 1 is not a factor of f of x. Okay, look at this. We tried for x is equal to negative 1, but we said x plus 1, a different sign. Okay, here x is negative 1, but we say x plus 1 is not a factor. So now let's try for x. X is equal to 1. Okay, and f of x will be we should put a 1 there. 1 will be equal to 1 cubed minus 7 1 plus 6. This is going to give us 1 minus 7 plus 6. This is minus 6 plus 6. This is a 0. Okay, so f of 1 is 0. So this implies that okay, we used x is equal to 1, so x minus 1 is equal to 0. So x minus 1 is a factor. Is a factor of f of x. So we have found one factor. So we need to look for other factors. So if you want, you can continue substituting the different values of x that we have here, or you can just divide the factor that you have found into the given polynomial. So let's divide that. Let's find other factors by dividing this into this given polynomial, x power 3 minus 7x plus 6. Okay, we're dividing this into that to get other factors. Okay, so we can use different methods of dividing. So let's use the synthetic division. This is the most straightforward. Synthetic division, how does it work? Okay, number one, first of all, you write your polynomial in descending powers over x. So the highest power is x to the power 3. The second power here should be x to the power 2, but there's no x to the power 2 in the given expression, in the given function. So you write plus 0 x power 2. X power 1 is given minus 7 x power 1 plus the constant. Then next you write the factor. We saw for this factor is equal to 1. Okay, when this factor is equal to 0, you get x is equal to 1. And then you draw this beautiful table here like this. You draw a line like this. Okay, then you draw another line like this. Then here you're going to put the value of x, which is 1. Then here you put the coefficients of x over the polynomial. So the coefficient of the highest power of x is 1, followed by the second is 0, the third minus 7, the fourth one is a constant 6. Once you write a constant, you close it out with another line. Okay, the next step is you drop this number here, you just drop it. Okay, then you write a 1 there, then this 1, okay, times this 1 there, you are going to get a 1. 1 times 1, 1. So you write that 1 here, then you add, okay, 0 plus 1, what do you get? You get a 1. Again, you repeat 1 times this 1 here, you get a 1. Then negative 7 plus 1, you get negative 6. Negative 6 times this 1 here, you get negative 6. The positive 6 plus negative 6, you get 0. And at this, when you are doing this, when you're dividing by a factor, okay, the remainder should always be a 0 here. The remainder should always be a 0 there. So now the quotient, okay, the quotient is going to have these coefficients here, okay, and its degree will be 1 degree less than the given polynomial. Okay, this the given polynomial has got the highest degree is of degree 3, so the quotient will be a degree less, okay, which is 2. And the second term will be, we have the coefficient of 1 plus 1x, which is just x, minus 6. Okay, so the quotient is x squared plus x minus 6. This is our quotient. Okay, now that we have this quotient, so it means that our given function or polynomial can be written as a product of its factor, the first factor that we had, and the second factor is this quadratic expression that we found. So let's factorize this one further. We can factorize this one further, factorizing it further. Okay, if you can't, it means you have to solve for the roots, for the values of x from this quadratic equation. Okay, so to find the let's factorize this one further. Our quotient x will be equal to x squared plus x minus 6. Okay, to factorize this one product, try first to see if you can factorize it using the product sum and factors. The product is 1 times negative 6, we get negative 6. The sum is here, which is 1. Then the factors, two numbers, when you multiply them you get negative 6, when you add them you get 1. So negative 2 and 3. When I multiply negative 2 and 3, I'm getting negative 6. When I add 2 and 3, I'm getting a 1. So it means my quotient will be equal to x squared plus 3x minus 2x minus 6. Okay, factorized in the first two terms. Okay, let's have that division there. In the first two terms, what is common is x. What remain there is x plus 3 remain there. In the last two terms, what is common is 2, negative 2, x plus 3 there. Then factorize, you can have x minus 2, x plus 2 plus 3. That is our quotient. So it means that this polynomial can be written as a product of its factors. Okay, then we have x minus 2, then x plus 3. Okay, these are the factors. So now to find the roots, equate this factor, each and every factor here to 0. To find the roots now, we should have x minus 1 being equal to 0, we should have x minus 2 equal to 0 and x plus 3 equal to 0 as well. Okay, so our x is equal to 1, our x is equal to 2, and our x is equal to minus 3. So these are the roots. Okay, so let's speculate here. When we draw our x or y plane, okay, the x there, the y, and the origin, we are saying that the roots, one is minus 3, another one is at 1, another one at 2. Okay, so it's either the graph looks like this, cuts there and then goes right up, or it looks like this. Okay, or it looks like this, goes there and goes right down. Okay, so which one is the correct one? So you're going to test using the table, okay, the position of this graph. Okay, so the table should look like this. We have 3 here, we put the roots 1 and 2. So we're going to get the numbers of the values of x4 that are less than -3, and those between -3, okay, and 1, and those between 1, x and 2, and those more than 2. Okay, so let's test these values. What will happen to the graph from here? Okay, going this side. Where is the graph? Is it up? Is it up, or is it down here? Let's test that. So pick any value less than -3. So let's pick, let x be equal to -4. Then substitute in the function, the given function. -4 will be equal to -4 minus 1 minus 4 minus 2 and -4 plus 3. Let's see what happens to the sign. So this is -5, this is -6, this is -1. Okay, this is going to give us -30. So it means that the graph is below here. Okay, so the red one fits very well. So from here we can even conclude that the graph moves like this, because there are only 2 options. So it means that the final sketch, this is a sketch not drawn to scale, x, y, 0 will look like this. 1 and quickly as 2 there. This is f of x. This point is 2, this point is 1, and then this point is -3. This is 0, and this is how you can sketch that. Now we need to do another example. For example, if we can't factorize the quotient here, if this cannot be factorized, okay, what do? Let's do that example. What do? Let's check out another video which is going to describe that.